calculating distance, and in particular distance to stars, though later we'll actually see the same equation for calculating distances to galaxies. So up to this point we've been comparing apparent and absolute magnitudes and qualitatively determining distance. So we had our general rule of thumb: if apparent is brighter, then it's closer than 10 parsecs. If they're equal, then it is 10 parsecs away. And if apparent is fainter, then it's going to be more than 10 parsecs away. Now we're going to actually get solid numbers instead of just this greater than or less than relationship. And so to do this, we're going to use what I have dubbed the big ugly distance equation, or BUDDY for short. This is definitely the ugliest equation you will see in astronomy too. So here we have 10, that's raised to the power of everything inside of these brackets. So all of that is going to determine what 10 is raised to the power of. And so defining our terms here, d, that is our distance, and this will give us our distance in parsecs. Little m, that's our apparent magnitude, how bright it appears to be. So that's the one that we get by just looking up in the sky. And then big M is our absolute magnitude. And that's the one that's so tricky. So we can get this from, if it's a Cepheid variable, we can look at the period luminosity relationship. If it's an RR Lyra, they always have the same absolute magnitude. Or if it's a main sequence star, then we can use the HR diagram to get the absolute magnitude. So those are our terms. What we're solving for is distance. That's what we want. So we're going to observe the apparent, and we'll observe something to get our absolute. So how do we use this? Well, here's a typical scenario. Sirius, which is the brightest star in the night sky. So it has a very bright apparent magnitude, negative 1.46. And we know from our spectral type measurements that it has an absolute magnitude of plus 0.14. So we want to know how far away is this star. So we've got our numbers. Little m is going to be negative 1.46. Big M, our absolute magnitude, positive 1.4. So we're going to plug this in to our equation. So here's our equation again. 10 raised to the power of all this stuff in the brackets. So we've replaced little m with the negative 1.4. We've placed big M with the positive 1.4. One thing to be careful of, we are subtracting that absolute magnitude. So if the absolute magnitude is negative, this will be an addition. Because you're subtracting a negative. So just something to look out for when plugging numbers into this equation. Now it depends on your calculator. Some calculators have the square brackets. Others prefer that you just do it as another set of parentheses, and then you can just plug it all in as one equation. What I'm going to do is break it down step by step, just in case you're not comfortable plugging all of this in one fell swoop. So the first thing we do, order of operations. Please excuse my dear Aunt Sally. Do you remember that? Please excuse my dear Aunt Sally. So the first thing you do are parentheses. And so the first thing we're going to do, the inner parentheses, negative 1.46 minus 1.4 plus 5, that gives us 2.14. So we're going to replace everything in the parentheses with the 2.14. We still have the minus 5. We can think of these as another set of parentheses here. So that's going to be our next step. What's in the second set of parentheses? So 2.14 divided by 5, you get 0.428. So again, you could put that in parentheses if your calculator doesn't like square brackets. And so in this case, our last thing is exponent. That's the E in the please excuse dear Aunt Sally. So you just take 10 and raise it to the power of 0.428. And when you do that, you get an answer of 2.68 parsecs. Yes, it's an ugly equation, but it does come in exceedingly handy when trying to calculate distances to stars, and later we'll be using it to calculate distances to galaxies. So our buddy equation is our buddy, even if it is big and ugly.